Welcome viewers. In this video we will see the capacitance of a spherical capacitor, the derivation and one problem. So the spherical capacitor is shown in the diagram, right? So we have inner sphere and outer sphere. In between the dielectric is filled. So the radius of the inner sphere is a meter. Radius of the outer sphere will be b meters, right? The charges are accumulated, positive charges and negative charges. So this inner sphere and outer sphere in between the dielectric is act as a capacitor. Now we'll see the expression for this, the spherical capacitor. So the description is given. The radius of inner and outer sphere are a and b respectively. The space between the two spheres are filled with a dielectric with a permittivity epsilon r. So our aim is to find the capacitance between inner and outer sphere. So we start with the electric field intensity, then we'll go to potential, then we'll find the capacitance. The electric field intensity is given by E equal to Q divided by 4 pi epsilon r square. That is the general formula. Here we can take as it is, right? So the sphere, we consider the sphere, so E equal to Q divided by 4 pi epsilon r square is taken. The potential is given by the relation between potential and electric field, V equal to minus integral E dot dr. So this dr is nothing but in between inner and outer sphere. We consider one radius in between inner and outer sphere. Now we'll see what is the limit for this integration. What is the limit? So the potential difference is the work done in moving a unit positive charge from negatively charged sphere to positively charged sphere, right? Here the potential, the work done is nothing but moving a unit positive charge from negatively charged sphere to positively charged sphere. That is from the outer sphere to inner sphere. So that the limit are from B to A, the radius of the outer sphere to radius of the inner sphere, right? So the limit is from B to A. So that V equal to minus integral B to A E dot dr, right? Now substitute the value of E. E equal to Q divided by 4 pi epsilon r square into dr. The limit is, now the limit is interchanged. B to A is now interchanged with A to B. So that this negative become positive, right? So Q divided by 4 pi epsilon is now constant. Only we have integral B A to B 1 divided by r square into dr, right? So Q divided by 4 pi epsilon, the integral 1 by r square is minus 1 by r. We know very well. So the integral 1 by r square is minus 1 by r. Substitute the limit a and b. So that Q divided by 4 pi epsilon, so this limit minus 1 by b. So while substituting lower limit, already one minus is there, we'll go one more minus, so it become plus 1 by a. Right? So that can be rewritten as V equal to Q divided by 4 pi epsilon 1 by A minus 1 by B. It is rearranged. Now we'll take the LCM. Q divided by 4 pi epsilon, take this LCM AB. So here B will be multiplied here, A will be multiplied here. So B minus A divided by AB. V equal to Q divided by 4 pi epsilon B minus A into AB. But what we need is capacitance. So substitute Q equal to CV. Replace this Q by CV. So that V equal to CV divided by 4 pi epsilon B minus A divided by AB. Right? This V got cancelled. Bring this term in the numerator. Bring this term in the denominator. So 4 pi epsilon divided by B minus A divided by AB is again go to the numerator. So 4 pi epsilon AB divided by B minus A equal to C. So that can be written as C equal to 4 pi epsilon AB divided by B minus A. So this is the expression for spherical capacitor with radius A and B. It is 4 pi epsilon AB divided by B minus A. Now we'll see one problem in the spherical capacitor, right? The radius of two spheres differ by 4 cm. The radius of inner and outer sphere is not given, but the difference between inner and outer sphere is given as 4 centimeter. Right? The capacitance of this spherical capacitor is 53.3 picofarad. Right? The capacitance value is given 53.3 picofarad. If the outer sphere is earthed, calculate the radius A and B assuming air as a dielectric. Right? So the capacitance value is given. The A and B values are not given, but difference between A and B value is given as 4 centimeter. Now we need to assume air dielectric. So with this given data, we need to find what is the radius of inner radius and outer radius, A and B. Right? So first we will see the given data. The difference between these two is B minus A equal to 0.04, 4 centimeter. While converting into meter, 4 into 10 to the power minus 2, that is nothing but 0.04 meter. The capacitance value is given 53.3 picofarad, that is 53.3 into 10 to the power minus 12. Picofarad means 10 to the power minus 12 farad. Then epsilon naught value is constant 8.854 into 10 to the power minus 12. Epsilon r equal to 1 because it is given as air as a dielectric. Right. What is the expression for cylindrical spherical capacitor? C equal to 4 pi epsilon AB divided by A minus B. Just now we got this expression. Right. So in this what we have, what we need, this AB, because A minus B also known value. So we bring this term here and bring the 4 pi epsilon in the denominator. So C into A minus B divided by 4 pi epsilon equal to AB. Right. So that AB equal to C into A minus B divided by 4 pi epsilon. This epsilon is written as epsilon naught into epsilon r. Right. Now substitute all the values. C is given as 53.3 into 10 to the power minus 12 into the difference between these two is 0.04 divided by 4 pi. Epsilon naught is 8.854 into 10 to the power minus 12. Epsilon r value is 1. Right. So by simplify this, what we got, 0.0192. Right. The AB value after simplification, what we got, 0.0192. But we know that B minus A equal to 0.04. From that, B equal to 0.04 plus A. Bring this A in this side. So that B equal to 0.04 plus A. Right. So now AB equal to 0.0192. So in this, you replace this B equal to 0.04 plus A. Right. This B is replaced as 0.04 plus A. That is equal to 0.0192. Right. So multiply inside. A is multiplied. So 0.04 A plus A square equal to 0.0192. Right. So rearrange this so that A square minus this term is brought here, minus 0.0192 plus 0.04 A. Right. So we'll rewriting A square plus 0.04 A. This A is available, 0.04 A minus 0.0192. So this is a quadratic equation. The A value is 1, B value is 0.04, C value is minus 0.0192. Right. So this the A value can be calculated from this general formula. Minus B plus or minus B square minus 4AC divided by 2A. Right. So this B value is nothing but 0.04 minus, already one minus is there, plus or minus. B square is 0.04 square minus 4 into A. A value is 1. That C value is minus 0.0192 divided by 2A. 2 into A. A value is 1. Now we need to simplify this expression. So that is simplified 0.04 plus or minus 0.04 square plus 0.0788. Right. So after simplification, what we have, minus 0.04 plus 0.018, the square of this value, and this 0.0768 divided by 2. Right. Now both the values are added together. 0.04 plus or minus 0.0784 square root. So while taking the square root, what we got, minus 0.04 plus or minus 0.28 divided by 2. Now we can divide by these two. So 0.04 plus or minus 0.28 divided by 2 can be written as minus 0.02 plus 0.14, right? So we can, two values are available now, minus 0.02 plus 0.14 minus 0.02 minus 0.14. So while doing this, what we got, 0.12 and minus 0.16. These two values are possible, either 0.12 or minus 0.16. But the value will not be negative, the value will be positive, so that we can take A equal to 0.012 means 12 centimeter, 0.02 meter means 12 centimeter. B equal to 0.16 mean it will be 16 centimeter, right? So A equal to 12 centimeter, B equal to 16 centimeter. See, the difference between these two is nothing but 4 centimeter. So what with the value what we calculated is correct, right? So we calculated the radius of inner sphere and radius of outer sphere.